For these two examples, we're going to use the shifting property for exponential functions. And the key to this process is to understand the Laplace transform of the original function versus that of the exponential function. So for our first example, e to the 4t times the cosine of 3t, you really have to identify the cosine's Laplace transform first, and then just shift that by s minus 4, which is the c number in this problem. So some people like to write this as the Laplace transform of cosine of 3t, which is going to be s over s squared plus 9. And then they write that we replace the s with an s minus 4. And when you do this, you have to make sure that you put the s minus 4 in place of both s's in the Laplace transform. So that's going to be s minus 4 over top of s minus 4 squared plus 9. And that will be the Laplace transform then of that exponential product with the cosine function. Down here, it's very similar, except you'll notice that this time around we have to look at the Laplace transform of the t cubed function. So that's going to be that power rule we talked about. And then we're going to be multiplying it, or using the exponential multiplier rule, and using s minus negative 2, which is s plus 2. So the Laplace transform of t cubed, we know is 3 factorial over one more higher power of s. So that's s to the 4th. But again, we're going to take our s's and replace them with s plus 2's. So we simplify down 3 factorial as 6, and then down below, we're going to actually have s plus 2 now raised to the 4th power. And you'll notice that, again, it's really the same transform as the t cubed, but we have just s plus 2 in place of the s. So hopefully that is helpful for taking these different kinds of exponential products with our functions.